Hi, we are from Group 12, testing bioimpedance BOCA X1. My name is Muhammad Shazwan and I am for the introduction. The major objective of this experiment is to understand the background of bioimpedance BOCA, find out the leakage currents and progress on performing electrical safety tests at specific IEC 6061 test limit using bender and region 60. BOCA X1 is a specialist machine that uses bioelectrical impedance to measure your body composition by sending a small electrical current through the patient's body. The current reads fat, water and lean tissue differently and can thus provide an overall picture of their body fat index. BOCA X1 is classified as a class 1 device, meaning this device presents minimal harm to the patient and generally simple in design with low to moderate risk to the patient and the user. A protective earth is applied on class 1 equipment. The implantation of 2 electrodes on the person's right hand and foot is all that is required for this non-invasive examination as the figure. So how the flow system of this device? First, the sine wave generator will supply AC current. Second, voltage control current source will lower the current until acceptable. Then it passes through the subject's body through wire connected. Fourth, there is an instrument amplifier. Then it passes through band pass filter. Lastly, it goes to AC to DC converter before it enters the digital subsystem. Next, I will pass to Shahir for the theoretical calculation. Thank you.
Hello, my name is Shahir and I'm going to explain the theoretical calculation. To find the leakage current, first we need to find the theoretical impedance. So the circuit is in series, so using the formula of R series, we find the R total, we got 11 kilo ohms. And then using the omega equals to 2 pi f, we insert in the impedance formula and we insert all the parameters to get 10,993.44 ohm for the impedance. To find the leakage current, using the formula V equals to IZ. So we insert the voltage that we get from the experiment and the impedance that we calculated. So we get 1.1825 times 10 negative 3 milliampere. For enclosure leakage current, we get 3.2747 times 10 negative 4 milliampere using the same formula. For patient leakage current, using the same formula also, we got 3.2747 times 10 negative 4 milliampere. And for the patient auxiliary current, same formula, we got 1.5464 times 10 negative 4 milliampere.
Hi, my name is Naili with matrix number 1720657A. For test procedure, we will use these 3 devices to determine the leakage current, which is bender safety analyzer, Regia 60 and our own design device circuit. First, for bender, we are doing automatic, semi-automatic and manual tests for both without and with applied pad. Bender was turned on and bioimpedance BOCA was connected to bender bar plug power cord into the test socket. The difference between without and with applied pad is the classification on the main menu screen of the bender. Next, for the single test, we are doing the testing for 2 tests, which is enclosure leakage current and patient auxiliary current test. We connect the bender to power supply and the device, then choose the option F4, which is single test. Next, we move to the region 60. We are doing the testing for earth leakage current and enclosure leakage current since the bioimpedance BOCA is class 1 type BF device. So here is the test procedure for both tests. Last, for design measuring device, we have designed a circuit following the IEC 60601 standard to test all 4 leakages current. First, for earth leakage current, here is the test procedure.
Okay, switch off the switch. Do this every time you finish recording one.
This is the enclosure leakage current test. We also measure for patient leakage current test and patient auxiliary current test. Last but not least, we also doing the protective or combinative test by using a multimeter.
Okay, continue.
Hello, my name is Razil Biazian, KMB 10026. I'll be explaining about the result for our project. The first test is regional test. So on this test, we have got 3 different values of current. First one is leakage current, followed by enclosure leakage current and loop current. Second test that we have done is bender test. This test have provided us with the most value of current. We have done this test using 4 different modes: automatic, semi-auto, manual, and single test. This is because some of the value can only be found using the single test. Then we have conducted the test using design circuit. We can find 4 different value of current using our design circuit: earth leakage current, enclosure leakage current, patient leakage current, and patient auxiliary current. Then the last test we have done is quantitative earth continuity using multimeter, PE continuity. This is the only test we have done using multimeter. So we got the value of PE continuity at 0.63. That's all for the results part. Next part will be explained by my group member, Abdallah.
My name is Abdullah and I'll be doing the discussion part. For the first device, Regel 60, we were able to analyze the earth leakage current and the enclosure leakage current, but not the patient leakage current and the patient auxiliary current due to the absence of the patient leads in the Regel 60. For the earth leakage test result, it was 0.0165 and the enclosure leakage is 0. For the second device, which is the bender, we were able to test 7 tests, including earth leakage NC and SFC, enclosure leakage NC and SFC, patient leakage NC, AC and DC, and patient auxiliary SFC. You can see the results in front of you. For the device that we designed, it refers to IEC 60601-1 body model. We were able to test 4 tests, which includes earth leakage, enclosure leakage, patient leakage, and patient auxiliary. By referring to the IEC 60601, all the measured values from the bender safety analyzer must be less than or equal to the distance value. The expected measure value, which is less than or equal to the standard value, that is the medical device, is in safe condition. That's all for the discussion.
Okay, now is for the conclusion. In conclusion, a circuit body model was built and conceived in line with IEC 60601. The bender safety analyzer, Rigel 60, and self-designed circuit were used to test the electrical safety of the body composition analyzer BOCA X1. We have determined the bender has higher sensitivity than the self-designed circuit based on the data analysis. The values obtained for the bender, Rigel 60, and the self-designed circuit are within the IEC 60601 safety operating limits. As a result, the body composition analyzer BOCA X1 can be considered to be safe to use. As a biomedical engineer, it is important to learn how to perform electrical safety tests using medical safety analyzers such as bender safety analyzer, Rigel, and safety 60. Compare the parameters obtained with the IEC 60601/1 test limits and determine whether the device is tested is safe to be used.